So today we're working on multiplying and dividing. Okay, multiplying and dividing. Well, rational expressions follow the same rules as fractions. Same thing. So how do you multiply fractions? What's the rule for multiplying two fractions together or three fractions together? What's the rule? Does anyone remember what the rule is for multiplying fractions? Close. You're going to multiply. You just multiply. You do cross multiply. You multiply straight across. Straight across. Okay, sometimes you go like diagonal. For multiplying these guys, you're just going to go straight across. Okay, so I'm going to do it a little different because I'm going to show you the steps that we're going to use. Okay, so I know if I multiply straight across, it's going to be 8. And if I multiply straight across on the bottom, it's going to be 28, right? But what I need to do is I'm going to write them together. Okay. The reason I'm doing it like that is because I'm going to see if I can reduce them. So 1, I'm going to break down everything on top and everything on bottom. So 1 is just 1. 8. 8 breaks down, if I was to do the factor tree, right? The factor tree for 8, I would get 2 times 2 times 2, right? 4 times 2, and then 4 is 2 times 2. Okay? And on bottom, I would get 2 times 2 for 4. And then 7, if I was to do the factor tree for 7, I can't go any farther than 7. 7 is it. Okay? And then what do they have in common on top and bottom? Well, they have a couple 2's in common, right? So on top, I'm left with 1 times 1 times 1 times 2, which is 2. On bottom is 1 times 1 times 7. That's your answer. So I did it the long way there. I know a lot of you are like, well, can I just go 8 over 24 and then divide them both by 8 or divide them both by 4? Yeah, you could, but it's going to help you in what we do later. Okay, break them down first and then look for what we could cancel out. Okay, division. How do we divide fractions? Does anyone remember how we divide fractions? Very similar to multiplication, actually. Does anyone remember how to divide fractions? So when you're dividing fractions, you multiply by the reciprocal of the second one. Keep, change, flip. Keep the first 4/9 stays 4/9. Oops, let me put this down here. 4/9 stays 4/9. The symbol changes. Changes to multiplication. Reciprocal means flip. Flip the second one. So instead of 5/6, it becomes 6/5. Keep, change, flip. Once you do that, then you can multiply straight across. Then it becomes a multiplication problem. So I get 4 times 6, and I get 9 times 5. Break them down. 4 is 2 times 2. 6 is 3 times 2. Okay. The bottom, 9, 3 times 3. And 5 is just 5 times 1. Okay. What do they look for what they cancel out? Let's see. I got a 3 here and a 3 here, and I think that's all that would cancel out. So on top, I get 2 times 2 times 1 times 2. 8. On bottom, I get 1 times 3 times 5. 15. Okay. So that's what we're going to do today. That's all we're doing today. That's all we're doing today. So today we're going to be seeing monomials, binomials, and trinomials. So the first thing we have to do is break them down. We know how to do that. Done that before many, many times. Okay? So the only difference between multiplication and division with rational expressions is division, you got to keep, change, flip first. Everything else is the same. Okay, it has one extra step at the beginning. Okay, all right, let's go to 2a. 2a. Okay, so multiply straight across. So I'm not going to multiply yet. I'm just going to write down everything I have. So when I multiply straight across, I have 6 times 4 and x to the third times x to the third. And on bottom, I have 7 times 3. Next, I'm going to do the same thing I did before, break them down. 6 is 3 times 2. 4 is 2 times 2. And then x to the 6th is just x times x times x times x times x 6 times. 7 and 3 can't be broken down. They're done. Look for what you can cancel out. Cancel out the 3. So on top, I get 2 times 2 times 2, which is 8. X to the 6th over 7. Okay. None of the x's canceled out. Okay. 2b. Same thing. Same thing, except the first step is different. The first step we have to change. Keep, change, flip. So I'm going to rewrite the problem. Second one flips. The symbol changes to division. Same thing. Multiply straight across. I get 9 times 5, x to the third times x to the third. And then 7 times 6. Nine is 3 times 3. 5 is just 5. 5 times 1. Here you can put all x. I don't mind if you write them out or you don't write them out, but combine them, okay? Because they cancel out on the bottom. But I see there's no x's on the bottom, so nothing's going to cancel out. And then I get 7, and then 6 is 3 times 2. Threes cancel out. I get 15 x to the 6th over 14. Okay. All right. Try C. The one. Flip it over the back. 2C. Try 2C on your own. Okay. 16 x to the 6th, and then 9 is left on the bottom. Okay. So those are monomials. That's how you do monomials. Now we're going to make binomials and trinomials. It's the same thing, though. It's the same thing. You guys have done that many, many times. Okay. 3a. I have two numerators. Numerators are on the top. Denominators are on the bottom. So what I do here is I color code them. Just to remind myself that I need to break them down, because that's going to be my first step. My first step is breaking them down. Okay? Breaking them down, whether they're monomials, binomials, or trinomials. Okay? Just going through each one of them so that I make sure I do it, so I don't forget it. Okay? So the first thing is green. The green on mine. It's a trinomial, right? Trinomial. We have steps to factor trinomials, right? They're on the board. We've used them many, 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 many times, right? We start with GCF. Is there a GCF for the green? No, right? Just one. Okay, skip that step. All right, let's go to ABC then. Okay. Multiplies to be negative 24, adds to be negative 5. Let's see. I think it's going to be 8 and 3. Negative 8. Okay. So I got x squared, negative 8x, positive 3x, negative 24. So factored, I get 8 minus x and x plus 3. Okay. The green is factored, so I can cross it out. I'm going to cross it out because it's done. It's factored. You don't have to cross it out. It's not necessary, but I just do it just to remind myself that I'm done with the green. The pink right next to it is x squared. That's a monomial. So how do I break down that monomial? How do I break down monomials? That's it. X times x. Yeah, x times x. Easy enough. The yellow now. The yellow. The yellow is a binomial. It's got two terms. X squared minus 9. So I'm going to use the binomial steps. First thing, the yellow. Does the yellow has a GCF besides 1? No. So is it difference of squares? It is difference of squares, right? It's got squared, it's got a minus, and 9 is a perfect square. 9's a perfect square because it's 3 times 3. Okay, so that one's going to factor. It's going to be x minus 3 and x plus 3. Okay, that one's factored. The orange is a binomial as well. So we use the same steps. Does it have a GCF? No. Is it difference of squares? Nope. Then it's already factored. Okay. Let's see. We got an x minus 8 binomial with an x minus 8 binomial. We have an x plus 3 with an x plus 3 binomial. Numerator on top just is x squared. And then on bottom, I get x minus 3. Done. That's as far as I can go. Okay. So it's just kind of a mixture of, it's kind of like what we did yesterday, what we've done the last 2 days, where you're breaking them down and stuff like that. It's just instead of one fraction, you have two fractions. That's it. Okay. All right. Let's do B. Okay, B. Division, right? It's division. So before we do anything, we have to keep, change, flip. So that's the first step. Rewrite it. So the first one stays. Sign changes to multiplication, and second fraction flips. All right, so here we go. I'm going to color code. Okay, so I'm going to go through this. So green. The green is x squared minus 9. Or sorry, x squared minus 49. That's a binomial. So we have binomial steps for factoring. Does the green have a GCF? No. Is it difference of squares? Yes, it is. Yeah, 49. It's got the minus, it's got the squared. It's difference of squares. So that one's going to be x plus 7, x minus 7. Done with the green. Pink is a monomial, right? So I got to break down 3 and break down x. Well, 3 is just 3. There's no other way to break down 3. And x is just x. That was easy. Yellow, to the 4th plus 7x to the 3rd. Binomial again. So I got a factor. So this one has a GCF. This binomial has a GCF. What is this GCF going to be for the yellow? What's the biggest thing they share? X to the 3rd. Okay. Here's the thing with GCFs. They go in front, right? They go in front. When they go in front, they become monomials. So x to the 3rd is no longer a binomial. X to the 3rd is a monomial, kind of like 3x was. Okay? So what's left when I divide them both by x to the 3rd? X plus 7. Okay, done with that one. The last one's the orange. The orange is a trinomial. So I have trinomial steps. GCF. No, it doesn't look like it's going to have a GCF. But it does. I will be able to do ABC with it. Okay. So it's got to multiply to be negative 42 and add to be negative 1. So what two numbers multiply to be negative 42 and add to be negative 1? Yep, there it is. 7 and 6. Negative 7 is negative, 6 is positive. Good. Hey, what's up? Hmm? All right. Done with all factoring. They're all been factored. Now I'm going to look for what they have in common. So I got an x plus 7 and an x plus 7. I got an x minus 7 and an x minus 7. Those make two giant ones because when you divide something by itself, it always makes itself. So on top, I have 3x. And on bottom, I have x to the 3rd and x plus 6. This is where some of you were having issues with it. Some of you put that into Delta Math and it said it was wrong. Why would it be wrong? This right here is a monomial now. X to the 6th, or sorry, x to the 3rd is a monomial. It's x times x times x. That will cancel out with one of those guys down there. Because it's in front, it's a monomial now, so I can do that. So now I just have 3 on top, x squared on the bottom. That's the finished answer. Just make sure, if you have anything like that, make sure. Sometimes the GCFs will do that because the GCFs, when they become GCFs, they also become monomials. Okay. Okay, so last one in your notes, we'll do one more problem together and then we'll be done for today. So 2 more. It's the last one in your notes, though. Okay, so I need to break this down first. It's multiplication, so I don't need to keep change flip. So first start with the green. The green's a binomial. So start with GCF. Does the green have a GCF? It does. The GCF for the green is going to be 6x to the third, right? 6x to the third. That's going to go in front. When I do that, it leaves me with x minus 5. Okay, green is done. Pink. Pink is a trinomial. So the trinomial, I'm going to follow those steps. The pink does not have a GCF. So what I'm going to do for the pink is I'm going to move it over here. I'm going to do ABC with the pink. A, B, C. Multiply to be 4, add to be negative 5. Negative 4, negative 1. So I got x squared minus 4x minus 1x, and then 4 down. Okay, so we get x minus 4 and x minus 1. Okay. Done with the pink. Now the yellow. The yellow is also a trinomial. So the yellow, let me write this down, move this over here. Does the yellow have a GCF? It does, right? You can divide them all by 6. And you get x squared minus 9x plus 20. So 6 is going to go in front. Now I have to do ABC with the yellow because I'm still not done with it. A is 1, B is negative 9, C is 20. Uh, 20, negative 9. The two numbers that multiply to be 20 add up to be negative 9. Negative 4, negative 5. Okay. So we get xx minus 4 minus 5. Just don't forget to put the GCF in front. 6 goes in front. And then the last one is the orange. That one has a GCF as well. It's a trinomial, so I'm going to do the same steps that I just did on the last two. That GCF is x. So I'm going to put x over here so I don't forget. Do it one more time. -1, -7. So I get x -1 and x -7. Okay. Broke down everything now. Broke down everything. Now I'm ready to start canceling things out. Okay. So x -5 and x -5, x -4 and x -4, x -1, x -1. So on top, I get 6x to the third. That's it. And on bottom, I get 6x, x -7. Again, if you put that into delta math, it will say it's not done yet. Because the monomials here can still be reduced. These two guys here are monomials. They both share 6. They both have 3 and 2 in common. So I can cancel these guys out. And then x to the third is x times x times x. So that'll cancel out with one of those guys. So now I'm left with x to the second power on top only, and x -7 on bottom only. Okay. And you're done. All right. Okay, so I'm going to give you one more to do in your notes. So wherever you're going to tape this in, we're going to do one more problem, and then we'll be done. I'm going to give you a chance to do this one on your own. So we'll call this one 3E. Okay, here we go. Okay, so I'm going to let you guys work with it. First thing I'm going to do, though, is the yellow. Look at the yellow. X plus 10 has a squared with it. What does that mean? There's 2 of them, yeah. So the first thing I would do is do this. Don't write that squared. Just write another x plus 10. And the yellow is actually already done for you. It was probably a trinomial, but they've already simplified it for you. So you just got to do the rest. Okay. All right, I'll let you guys work on it, and then we'll go over it in a few minutes, and we'll be done. Okay, so I factored everything. The green was a binomial, so I factored GCF is x, but then when I factored out an x, it was difference of squares. So I had to take that into account too. The pink is a trinomial with a GCF. So I remember to put the GCF and the factored form. The yellow we talked about before, that one's already done. The green, or sorry, not the green, the orange is just a trinomial, no GCF. Okay. So that's all the heavy lifting. Now we get to cancel things out. X minus 2 and x minus 2, x plus 10 and x plus 10, only one of them, because I only have one on top, so I can't cancel out both. And then x minus 6. Okay. So what I have left on top is x plus 2, and 2. So the monomials I can put together to make 2x, x plus 2. Because x and 2 are monomials. They're not binomials, so I can put them together here. And then x plus 2 is a binomial. On bottom, I have 4 times x, or 4x squared, and x plus 10 left. The x's I can cancel out. They're both monomials. I can cancel out the top x with one at the bottom. And 4 is 2 times 2, which cancels out with one of those 2's. So I got x plus 2 on top and 2x, x plus 10 on the bottom. And you are done. That's as hard as they'll get. That's as hard as they'll get. They won't get any harder than that. That one, D and E are kind of the hardest ones they'll get. Okay, just remembering, it's not hard, it's just remembering to factor everything. That's the biggest, when I see mistakes, it's this part here. Forgetting to cancel those guys out and these guys out. Okay. All right. Okay, so tape that in, and then we'll do some practice tomorrow.